Before we start looking at the details of this print check function, let's take a look at these classes. We'll take a look at the code as it's presented in the book. So this is what my main looks like. So what I do is I set up two employees. I use the two ways of setting up objects. One is a statically allocated object versus dynamically. So I use pointers and use new. And then I have a matching delete over here for my new. So whenever I create an object, I delete it. And I create a salaried employee object and an hourly employee object. Okay, so as you can see in this tooltip, hourly employee inherits from employee. Okay, so this is how you set up inheritance in C++. You say whatever class you want to set up. Instead of saying, as you would in Java, extends, you use the colon, and usually, almost always, we will use the public. We'll use public inheritance. There's also private and protected, but we very seldom have to use that. Okay, so let's take a look at those classes. Here is our employee class. We put it in our own namespace, and that's how the book has it too. It's a very simple class. This does have a print check function, and we'll look at that in just a second. So there's the employee.h, that's the base class or the superclass. There is a print check function that's implemented, but all it does is print out an error message saying this really should not ever be used. So we'll take a look at that pretty soon. First, let's take a look at one of the subclasses, or the derived classes as they're called in this book. So for example, salaried employee inherits from employee, so it gets all of those methods plus some other things. One of those things is the print check function. And let's take a look at what the print check function for salaried employee does. It gets the name, the net pay, and then prints it out. And the net pay for a salaried employee is just, I think, just a weekly pay. Also, we do things like get the social security number, and of course these are just made up examples. Alright, so very simple class. Now let's take a look at the hourly employee class. Alright, here's hourly employee. It inherits from employee, and it has a wage rate and the hours worked. Okay. And then HourlyEmployee.cpp has basically the same kinds of things. It also has a print check, and there's a function to set the net pay, and get the net pay as well. Okay. Alright, so this is all straight from the book. If you want more details, if you want this program set up, definitely look at chapter 14 in the book on inheritance, the chapter on inheritance. Alright, so what I did was I created a couple of objects, one statically allocated object and one dynamically allocated object for each kind of employee. Okay, and then what I do is, of course, if you have statically allocated objects, you use the dot operator to access the print check function. If you use dynamically allocated objects, you have a pointer, and so you have to use the arrow notation to get at the same kind of thing. So you just want to try this out. Set up classes, create statically and dynamically allocated objects. Alright, and if you run this, you just compile this and run it. There's a whole bunch of output. Let me see if I can display it all. So this just creates checks, pay to the order of first person, $50. And it's got, I guess, the social security number. I got another one for Jenny, that's the second person. The third one is Penelope, fourth one is Adam. These are all salaried employees. They have a rate and hours worked, and from that you compute the pay. Okay, so try this out. This is straight from the book, and then all of the notes will make sense. Okay, so what you will see is that the print check function of the employee class will always be redefined in derived classes. So the two derived classes we looked at were salaried employee and hourly employee, and we saw that the print check function there works. There it was redefined, or in Java we say overridden. So the different employee types can have different checks. It doesn't make any sense for there to be an undifferentiated or just plain employee object. And you can actually do it. You can actually make an employee object. It's not hard. So let's just try it out. Let's say at the very end we say employee. It doesn't make sense to do it, but you can. You're not prevented from doing this. So we'll just say E1, and then we'll pass in Tom, and I don't actually remember what all the fields are in the constructor. Let me just check and make sure this will compile. Okay, so I have to check the constructor for employee.h. There's a name and social security number. Okay, so we have too many parameters, too many arguments. Huh? All right, that should work, I hope. Let's compile this. Okay, good. Now just, well, we don't have to check it out, but let's just do it. Employee star, that is, we set up a pointer. E2 is equal to new employee, and let's set up a social security number, and that's it. Alright, so one thing we will see is that the print check function is defined for employee, and so let's use it. So all this compiled, and then so let's say E1 dot print check. So there is a print check function, but what it'll do is it'll exit, and I don't know if you remember seeing it, but we at the very end of that print check function is an exit. So let's take a look at that. So this is never meant to be called, and so that's why we print out an error message in the print check member function of the employee class. This is never meant to be called because you're never actually supposed to instantiate employee. And so in Java, remember, we would make this an abstract method to actually never even allow a program to instantiate employee. That's what we would use in Java. So there is this exit, call to exit. So what will happen is you will print E1, you'll print out an error message, and you'll exit. You'll never print out E2. So if everything works, that's what we should see. Let's check and make sure we can compile it and run it. Okay, so here it is. If you look here, you did print out something for Adam. That was this employee right here, hourly employee number 2. And then the next call to print check was over here for E1, and it printed an error function and exited, so it never printed anything for E2. So all of this compiles, but you never reach this point. Okay, so once again, there may be classes that you never mean to actually instantiate, and in Java, remember, we can make classes abstract and prevent class like employee from ever being instantiated, even if it's just checking. Okay. So when you derive a class from a base class, so for example, hourly employee is derived from employee, you automatically get all the member variables and all the member functions. So the derived class, we say, inherits from the base class. We can also, in the derived class, redefine all of the existing members that we got from the base class, or we can add our own new members. Okay, so all of these things you've seen in Java, I hope. And so I'm going to skip this example, which we just saw in Eclipse. So we concentrated on the printcheck function because that's something, it doesn't make sense to have a printcheck function for a generic employee. Okay, so this definition and the .h file begins the same as any other definition. You have this pound if and def, include required libraries. Now what I did was a slightly different from the book. What I decided to do was I tried to avoid, so in, for example, employee.h, I don't have, I do have one pound include. Oh, I need that. Actually, you know what, I'm pretty sure I can get away with not having this. So the book has this, and I guess I just did the same thing as the book. What I would say a good rule of thumb would be that if you can avoid having pound includes, do it. So now I got a whole bunch of error messages, which I can, I think, fix by putting this after all the using statements. Okay, let's see if I can fix that. So this is a good thing to try to do. It may not always be possible. But if you can, remove all the .h's from your file, remove all the pound includes from your .h files. Now I gotta fix more stuff to make this possible, but it's definitely, I would say it's worth it. So here I will need a pound include string, and then using std string. All right. I know it's a little bit painful to try to stick to this, but there, it worked. So the reason we do it this way is that, or at least I prefer to do it this way, is that now when you pound include this, right, this is pretty clean. It's got just the minimal amount of stuff, just the bare things that you need. And so you're less likely to have name pollution. That is, when you use, for example, using namespace std, if you put that in here, now any file that pound includes employee.h will have all that stuff. And this way you have a chance of keeping client classes of this class relatively clean if you want to. So I believe I did the same thing for salaried employee. You do need pound include for the base class. Since you inherit from employee, you definitely do need this. So you can't get away from that. But if this is clean, then this, if the employee.h class is clean, or the .h file is clean, yeah, this will also be clean. And also, if you look at HourlyEmployee.h, you can do the same thing. Keep it pretty clean. So that's a good thing to strive for.